Alright, one of the purposes of this aspirin lab is to introduce you to the concept of percent yield. So let's take a look at our reaction. This time I'm going to simplify a little, and we're simply going to say that we have salicylic acid, and we're reacting it with acetic anhydride. To yield aspirin, and acetic acid. When we conduct this reaction, we are using a huge excess of acetic anhydride. And by that I mean we are using way more of our acetic anhydride than we need. Also, I would note, we don't really care about acetic acid. We're not interested at all in any acetic acid we produce. We're only interested in the amount of aspirin, and that amount of aspirin is limited only because we're using such a big excess of acetic anhydride. It's our quantity of salicylic acid that limits our production. It's what limits the production of our aspirin. For every 138 grams of salicylic acid you use, every 138 grams of salicylic acid we use should produce 180 grams of aspirin. In other words, let me rephrase this. In other words, we have a ratio of 180 grams of aspirin to 138 grams of salicylic acid. Now, we have some special names here and some special terms that we want to throw out and familiarize ourselves with. I wanted to refresh my screen here, so let me recopy the reaction real quickly for you. Because we have this excess of acetic anhydride, and it's salicylic acid that's limiting our production, we refer to salicylic acid as our limiting reagent. A limiting reagent is the substance that limits the production in a chemical reaction. And for this reaction, because we have an excess of acetic anhydride and it's our amount of salicylic acid that's limiting our production of aspirin, the salicylic acid, salicylic acid is the correct way to pronounce it. I'm going to mispronounce it 20 times because my tongue trips over it, is our limiting reagent. So let's take a look at the math that we'd be doing here. If we use 3.678 grams of salicylic acid, how many grams of aspirin should we be able to produce? Well, we only have one number in this problem, so we know we're going to start our line with it, 3.678 grams of salicylic acid. We just learned that for every 138 grams of salicylic acid we have, we should be able to produce 180 grams of aspirin. So that's our ratio of aspirin to salicylic acid that we can use to solve the problem with. Since our grams of salicylic acid are canceling out, the problem must be set up correctly. We punch that into our calculator, and we get 4.80 grams of aspirin. Quick note on sig figs here. In the lab, your balance is going to be giving you 4 sig figs. I better see those 4 sig figs in your lab book or I'm going to get very grumpy. However, the way you're doing the calculations here, and that's 180 point, your ratio has only 3 sig figs, so you're going to reduce your number of sig figs to 3 sig figs down here. And that's going to be the same thing that's going to happen to you when you perform the lab. So watch out. I just told you the sig figs, so I'm going to be tough grading for you here. All right. So if we have 3.678 grams of salicylic acid, how many grams of aspirin should we be able to produce? 4.8 grams. In theory, we should be able to produce 4.8 grams of aspirin. That's the quantity we should be able to produce in theory. The quantity of a substance you should be able to produce in theory is referred to as your theoretical yield. based on stoichiometry, which is a fancy way of saying the chemistry of math, the math of chemistry, based on stoichiometry, the amount of product you should be able to make. That is known as your theoretical yield. Now, in lab, you'll discover that the lab seldom reads the book. So, at the end of the experiment, with which I started 3.678 grams of salicylic acid, at the end of the experiment, with which I started with 3.67 grams of salicylic acid, I produced 2.5823 grams of aspirin. In other words, when I actually performed the experiment in the lab, this is what I actually produced. This quantity that I actually produced is referred to as my actual yield. And your actual yield is what you actually get in the lab, right? As chemists, you want to evaluate how good you were in the lab. To evaluate how good you were in the lab, we like to use a quantity known as percent yield. And percent yield is the ratio of actual yield divided by your theoretical yield. In other words, we're taking the ratio of what I actually made and dividing it by how much I should have made if everything had gone perfectly, and then changing it into a percent. So actual yield divided by theoretical yield times 100. So for our scenario here, I had an actual yield of 2.5832 grams. In theory, I should have produced 4.8 grams. So my percent yield for my experiment was 53.8%. And I'll tell you right now, in today's lab, you're generally going to go to one of the two extremes in the process that we're using today. You're either going to not get rid of all your water, and you're going to wind up with a percent yield over 100, which means you have a contaminant, or you're going to wind up with a very small percent yield, 50, 40, because you got your substance really pure. It's generally in the laboratory a trade-off between the amount you can produce, the amount you can collect, and the purity of what you can collect. Such a decision was never had to be faced by Captain Kirk. Why don't you write down Kirk? K-I-R-K, Kirk.